Example 8 asks us to write a new function based on the given function and the transformations in the given order. So we were actually given a set of directions here, and so we want to make sure we write this stuff in the proper order. So before I actually write the equation, let's actually write the appropriate moves we should be making with each of these. So if I want to shift any function of f of x 5 units to the left, well, I do that by plugging in x plus 5 inside of it. If I want to vertically stretch it by a factor of 2, I do that by multiplying f of x by 2 on the outside. If I want to reflect a graph across the x-axis, right, I'm going to do this here, right? So if I want to flip a graph this way, I need to change all the signs of the y values. So we do that by multiplying it by -1 on the outside. And if I want to shift a graph down 3 units, I do that by subtracting 3 on the outside. So A now says write our equation of f of x. So I'm going to now apply all of these moves to my equation. So g of x, on the outside of the function, I'm supposed to multiply it by 2 and by -1. So I'm going to get -2. On the inside, I'm supposed to plug in x plus 5. And on the outside over here, I'm supposed to subtract 3. So these are the moves, right, when we've combined our moves that I'm supposed to do. Now, to apply it to our specific function, the square root of x, well, it's 2 times the square root of x plus 5 minus 3 on the outside. The next thing we're asked to do is to sketch a graph of g of x. So this can be kind of difficult to do if you don't have the original graph of f of x to look at. So what I like to do is I like to plot the original function, find a couple of points, and then move those points and redraw my graph. So let's look at the graph of square root of x. So we know that you can't have any negative numbers under that graph. And so I'm going to plug in some values from x and plot them. And I'm going to plug in numbers that are perfect squares, so it's easy for me to plot. So I know the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The next perfect square we have is 9, and the square root of 9 is 3. So this is 0, 0, 1, 1, 4, 2, and 9, 3. So the graph of the square root of x looks like this. So if I look at my set of instructions that I was given, the only thing that happened to the inside of the function, or in the x direction, was we shifted the graph 5 units left. So that means subtract 5 from my x values. In the y direction, we multiplied by -2 and then subtracted 3. So we can plug all the y values into -2y minus 3. And remember, all f of x is, right, once you plug the x values in, f of x are just the y values that come out. So this is the same thing we did in the previous problem. Plug the old y values in and evaluate directly. So all I really need to do this for is, let's see, a couple of points. So let's start with 0, 0. So if I subtract 5 from the x coordinate, I get -5. If I plug the y value 0 into here, I'll get -2 times 0 is 0, minus 3. The next point was 1, 1. If I subtract 5 from 1, I get -4. If I plug 1 into here, I get -2 times 1, which is -2, minus 3, which is -5. And I'm going to do one more point because I think we got enough room on our graph to plot one more. So let's do 4, 2. So subtracting 5 from 4 gives us -1. And if I plug 2 into here, I'll get -2 times 2, which is -4. And -4 minus 3 is -7. So these are the new graph points I want to plot. I'm going to plot these in a different color so we can see them. So -5, 3, or -5, -3, excuse me. There's -5, 1, 2, 3. Here's -5, -3. -4, -5 is here. And then -1, -7. So now if I start connecting these dots, and if I try to plug in 9, 3, well, 9 minus 5 would take me over to 4. And if I plug 3 in, I'd get -6 minus 3, which would be -9. So I can actually say 4, -9. So I can actually even get all the points on there, and we can see this graph is doing something like this. So this is going to be 2 square root of x plus 5 minus 3. If we go back up and compare these two, we can see all the moves. Well, this graph clearly got shifted 5 units left, right? It got vertically stretched. These points got further, the y values got further apart by 2 units, a factor of 2. We reflected over the x-axis. We can look at the shape and see it folded down under. And then if we had just flipped it over the x-axis, this point should have been here, but we can also see that after we flipped it, all the y values got moved down 3 spots.